Ooh, do I have a fun video planned for you today. Hello and welcome to another Solana tutorial. This one is actually more of a programming challenge than a tutorial. So if you're up for a fun little challenge, this is the right thing for you. Today we're gonna do the opposite of what you usually do. Because usually you program, you encounter an error, and you try to get rid of it. But today, we're gonna do the opposite in that we try to have errors happen. We try to cause errors. Now you might be like, why the hell would we want to do that? To which I would respond, well, to learn something. This is actually inspired from one of the first classes that I did at university studying computer science. It was a module on C programming, and as an exercise they had us create compiler errors. And I really enjoyed that exercise, for one, because it was fun. It brought out the hacker in me. And two, you really learn something. When you cause the error yourself, you're then much more capable of figuring out what's going wrong if you encounter that error later on when you actually try to not have errors. So that's why we're doing this today. Let's dive into Solana errors. Let's go to the kit. Because first of all, we need to figure out what errors there are. And this thing, as far as I know, has add Solana /errors. Errors, there you go. So yeah, Solana /errors. This package brings together every error message across all Solana JavaScript modules. So those are all errors, which, you know, is gonna be a lot. But let's check. We've got error that exports the Solana error. Then we got codes. I think that's the interesting stuff. Yeah, here we have all of the error codes. Starting at block height exceeded, invalid nonce, to some RPC errors, address errors, account errors, key related errors. And then I think the most interesting ones to us are gonna be the not instruction related, but probably the instruction errors. And there are a lot of those. And then the transaction errors, which probably also are in here. Yeah, here. Well, this is transaction related and this is transaction errors. Transaction related probably means when you're trying to send a transaction, something already fails, like fee payer missing, for instance. I mean, those names are very verbose anyway. And then the transaction error, those will actually happen when the transaction is executed and there is an error, I think. See transaction error, TS. Yeah, we've seen some of those before. If it's an instruction error, you get the instruction error. Oh, this is fun because an instruction error is a transaction error, as we learned in some of the previous videos. Cool, so the kit already makes it nice for us and formats that nicely. So that we will need when we actually encounter errors, that it's neatly displayed, but that happens automatically behind the scene for us already. We don't, manually have to call that stuff. And yeah, RPC related errors, RPC subscriptions related errors. That seems to be very probably when we're using the kit. And then we have a Solana error code, which is any of all of those. And an error code with a cause is just this one, the JSON RPC error, server error, send transaction pre-flight failure. Is it also in here? It's also in here. The send transaction pre-flight, because that has more info, it has more context. Code with cause. If we get that error, there's more information in there, so that's why this is a different type, I guess. But in any case, what are we gonna do today? We're first gonna have a look at this error package, and then we're gonna try to create errors ourselves. And obviously, there are, roughly 300 errors. I'm not gonna go through all of them, because that will take me days, but we'll see how far we get. If I would manage all of the instruction errors, that would be already a lot. So JSON RPC, if we call the RPC and something doesn't work, but that's not so interesting. Those are also interesting though. Why are they so low? What kind of error is that? They seem to be errors from the kit. Malformed big int string. Actually, do I have the kit? I've already once cloned this. And in here, Lampert's out of range, for instance, seems like a very kit-like error. So on the one hand, I have the kit, and then I'm just npm-ing the kit as well. Here, I'm just going to use it. And at errors, catching errors, there we go. When you catch a Solana error, assert its error using is Solana error, you can use that context to render useful error message or to make context-aware decisions. So, for instance, I'm just gonna copy all of this. At Solana errors. Aha, there we have an incompatible name, but not so important. Let's just go with the basic error missing signature for fee. This doesn't exist anymore. Great. So we're catching an error, and then we can say even more basic, if is Solana error, this E, this is a Solana error. And then here in this example, it shows you can check if it's a specific error and then handle that. For instance, Lampert's out of range. I want to try to get this one, and I can import it from errors. And here I can be like, you found, I want to get a message. There's also a way to get, this will give me a number. Is there a way to get from the number to a name? Somehow through this Solana error message. So Solana error message. Wait, where is this? How do I get to this? Shown to developers in developer mode, but can I, it is exported. Oh, wait, this is exported, is messages not exported? Get human readable error message. Yeah, that's what I wanted to do. Message format string, I wanted to do exactly this, but I don't have access to Solana error messages. Right, so the error itself has the message. That means that thing, if it is a Solana error, it must have a message. From supers, that's the error. Name is Solana error. Okay, so here I could double check e.name. This should give me Solana error. And here I can get the message out of the error. I can't, if I have the error code, get the message. This is not exported, but usually you go the other way around anyway. It's just this time we try to go. But yeah, whatever. Here I get the message, and then I can say, congratulations, you found the something like this. And now we just need to actually find that error. Lamperts from the Solana kit. You want a big int, and this way I would not get the error because one Lampert is just fine. But if it is 2 to the power of 64, then I should get that error. Huh? Yes, I am getting this error. Nice. This is a Solana error. Name Solana error. So this and this works. I'm gonna remove that again, but just so we saw that as well. And then we even found this specific one. We even found the Solana error Lampert's out of range. Congratulations, you found the Lampert's value must be within range. Error. Nice. And then, because we still throw E, we get the entire. This is what we would see, you know, if we wouldn't catch it, then we would just see this, but we catch it and then we throw it. So it's if we didn't catch it. So we see in this file, this is the error that's being thrown, and it's a Solana error. Lampert's value must be within range, shalalala, and that's the stack trace. And we see again the error code from the context. This code is number 6. Nice. So that's a good example. I'm not gonna throw in the future to be more compact. This is what it's gonna look like. Bam. This is a Solana error, and we found this specific error. Nice. And that was for Lampert's. So for this specific error, again, I'm assuming that those are kit related errors. This is the error that we're trying to find. Actually, let's do find. There you go. Okay, so this is our template. You put your code here and you try to get there. And I'm not actually too interested in those errors. Maybe a bit in the ones from the RPC, but even there, no, because internal errors, this is gonna be difficult to node unhealthy. This is, you know, we don't wanna get there. Those could also be somewhat interesting actually about addresses. Let's do one of those at least. You know what, from each block, let's do at least one from each block. Which one is going to be the easiest? Transaction signature verification failure. This should be easy. Or send transaction pre-flight failure. This is going to be super easy. Method not found is going to be easy if we manually send. Invalid request probably is what we get if we request an airdrop from mainnet or that. Some access violation kind of a thing. But it's probably method not found. I'm having a hard time deciding what I want to start with. Let's try and get invalid parameters. Actually, just because I see it here now, I'm interested what error this is gonna be. I'm not gonna get the invalid parameters. What would I expect? I would maybe get method not found. But even that, I think it's a different error. However, let's see. Error RPC. Oh, I need to send this. This is always the same. Dot send. And this is 410. Is it a Solana error? It is a Solana error, but it's an HTTP error 410 gone. It's a Solana error, but it's not the error that we expected. It's gone. It's an HTTP error. Probably a Solana RPC transport HTTP error. Is it that? Yes, it is a RPC transport HTTP errors, but that's in RPC related errors. Yeah, it's related because it's the protocol where we interact with the RPC that is giving us the error, not the RPC itself, kinda, even though it comes from the RPC, but it's an HTTP error. The RPC says, no, not even gonna handle that request. I'm not gonna give you my error, not even accepting this. I'm giving you a 410 HTTP error. The 400 errors are the it's your problem. The 500s are it's my problem. Server error, but no, you request something invalid. Anyway, so, okay, we found an error that we didn't really want to find, but cool. Now, I mean, that's how I find this one. Airdrop on mainnet. If we airdrop on devnet, what do we think we're gonna get here? Either no error because we just manage to get an airdrop, or otherwise it wouldn't be a transport error. It would probably be a JSON RPC internal error. No, it's not invalid parameters. My guess would be it's an internal error, but that is so generic that, you know, could be anything. Let's just run it. Yeah, it is an internal error. Score. But also, can I get the entire error? Oh, this time I get a different one. This time I get, again, a transport HTTP error with a 429 too many requests. So this is once again as we had before. But the first one actually was the internal error. Damn it, but I missed to log it properly. So, well, whatever. From now on, we will log like this as well. Okay, but we found one internal error. So you see how I'm doing this, right? I want to now get to a method not found. Although that's pretty abstract actually, because who manually sends RPC requests? Well, I might manually send RPC requests. So maybe we should be moving on. On the other hand, a transaction signature verification failure, that's also a neat little one, or this one, the transaction pre-flight failure, because those are the ones that we usually get a lot. But then on the other hand, that's exactly why it's easy to find those. And we usually learn more if we try to find the ones that we've never seen, because then we learn about those. Because here you can, if you try to get to those, then you really learn something. You know, see, my goal was kind of to get to all of the errors, especially all of the instruction errors and all of the transaction errors. That was my goal, to hit them all. But maybe it's smarter to just pick a few that are interesting, or make more videos about that. Because for those, we will need to have our own programs probably for most of those to get those. And again, it's going to be difficult to build transactions ourselves like that. But you would learn a lot if you get to all of those. And really, my challenge for you is that you try it yourself. Try and hit each of those errors yourself. Or pick one and be like, this is the one I want to try and get to. You will learn something. You have the template. I'll also put it on GitHub. And I mean, it's not difficult. And I recommend that you use the kit just to get used to that. You can also, if you're more comfortable, you can also use the Web3.js or your own implementation. That probably makes it even easier, because the kit and the Web3.js, they try to protect you from making those mistakes and, you know, getting those errors. So in a way, if you do it more manually, it could even be easier. But we will see. I don't want to get stuck with the RPC stuff, even though there are some cool ones that I want to hit here. But I'm currently way more fascinated about those, the addresses. So let's hit a bunch of those. The easiest will probably be this one. I would just do address from 0x lol, because that's not base 58. And nope, not hitting the one that I want. What am I hitting? Expected base 58 encoded address string. Oh, so first it checks the length. It is a Solana error, but first it checks the length. So what we're getting here is string length. No. Which one are we getting? Yes, this one. Out of range. Well, out of range can also be it's too short, right? Because the range is exactly this. So this is the error we're currently getting. Yeah. Actual length is 5 and it must be at least 32. Because the shortest address is 32 0 bytes, which would be, you know, the system program. There you go. That's the shortest address that we can have. So that's a valid address. And as soon as if we have one fewer, or that's one character fewer, then we get this error. Because now we're at length 31. So first it checks the string length and then it checks the byte length. So if I would add another one here, then the string length would be okay because it's 33, but it would be an additional byte. So then it's also 33 bytes and an address just has 32 bytes. So there I would get not the string, but the invalid byte length, I think. Yes, here I get the invalid byte length. Actual length is 33. So that's those two. And then invalid base 58 encoded address. Well, that would be if I had, I don't know, a 0 or something. And no, what do I get here? For alphabet. So the code is, oh, that's a very different code. Ah, in codex. So that's a codex error. Haha. Yeah, because the kit is working with codex and it has a bunch of errors for codexes. For instance, invalid string for base. In our case, base 58. Okay, but back to my invalid base 58 encoded address. How would I get to this then? It would be nice if I could see where this error is being thrown. I find out reference to this. Yeah, okay. It's getting more difficult there then. I don't know how I would get to this one. Yeah, here it's also just the invalid byte length and string length out of range. So even that thing doesn't throw it. Maybe that's from the old Web3.js. Maybe the old Web3.js still has that. And that's why it's still in there. Because the Web3.js didn't have the codex stuff yet. The codex stuff, that's what the kit uses. So that could be. So it could be that you, with the kit, can't even find all of them. And that's okay. As long as we're learning something. Invalid public key malformed PDA. PDA bump seed out of range. If you provide a bump that is larger than 255. Max number of PDA seeds exceeded, or max PDA seed length exceeded. Those are fun because there are limits to PDAs. So let's dig a bit into the PDAs. I want to try and hit this one, and this one. This one I think will be almost impossible because I think that's the one that we get when we don't find a bump that has the address B of curve, but that would mean that there are 256 invalid bumps, and the likelihood of that is super low. But there is an error for it, just in case it ever happens. So I think this one you will realistically not get, unless I misunderstand what it says. I just read the error code here. I mean, I could find it in the messages. Maybe that tells me more. Unable to find a viable program address bump seed. Yeah, well, doesn't really tell me more. I guess that's what it is. So yeah, I don't think we can ever find this one. But those three, I want to hit them now. Let's start with max PDA seed length exceeded. So for that we want to find, but no, I think here it's get program derived address. For program, I don't know. Let's do the system program. There you go. Okay, that works. So if I want a max PDA seed length exceeded, then I think I need to have more than 32 bytes in a single seed or something. So that's 32. That will still do. And one more. Yep, fails, but not with the error I expected. The seed at index 0 with length 33 exceeds the maximum length of 32 bytes. And that's not a max PDA seed length? Nope, that's not even a Solana error. Hold on. Throw new Solana error with exactly this one. And then we get a Solana error with 280007. That's exactly this one. Wait, well, why am I not catching this? Is that in a different thread or something? Is that... Oh, because that's async? Yeah, that's async. But if I await this, then we should be in the same one. Yeah, and then we get the congratulations. See that index 0. So this one, the first one, has a length of 33, but the maximum is 32. Nice. Okay, so that was for one seed. So that's the max PDA seed length exceeded. Then we can also do max number of PDA seeds exceeded. I don't know how many we can do. I don't know what that max number is. Actually, probably the message would tell us. Would the message tell us? Maximum of max seeds, including bump seed and max seeds. We don't know what they are. Okay, let's just do a bunch of them and then we'll... So, 1. 10 will still be possible, I'm pretty sure. I could make a for loop, but let's do 40. That will probably exceed already. Yep. Maximum of 16. I can have 16 seeds at most, and I put in 41 because 40 plus the bump. Okay, 16. This will already be too much. One too many, because now I have 17. But if I remove this one, then it should be fine again. There we go. And this way we learn how many seeds we can put in a PDA. This is not knowledge that I had before, but because I try it out and I try to cause that error, I learn. That's why I find this so fun. Well, I find it interesting. But what could be fun is to do this. PDA ends with PDA marker. This is probably going to be a difficult one to hit, but I want to try. Challenge for you to also hit that one. This one could be an interesting one. We want to get to this one. It ends with PDA marker. So let's check in the kit. Program derived address. Oh, wait. Here we see it. Here we see it. That what I said earlier, that this one, the one that's going to be basically impossible to find. The addresses fail to find viable PDA bump seed. That only happens if we loop through all possible bumps. 256. Wait, 0 seems to be not a valid bump. So 255, fine. But that's just an implementation thing, because we will never get to 0 either. So yeah, this will basically be an impossible thing. But this is done with create program derived address. So it's doing the create program derived address. And if you get a Solana error for the invalid seed point on curve, that's how you could do this one, by providing, you know, an address off the curve or on the curve. Invalid seeds, because they point on curve is what that says, pretty much, I think. So I want to get to this one. PDA marker bytes. That's what I was looking for. Because every PDA also has program derived address as a string as the seed. Additionally, so if we have a look at that, we had a look at that in one other video as well already. Yeah, there we get the seed bytes, program address, and then the PDA marker, and SHA-256 that. So apparently it is not allowed to have the PDA marker somewhere in the seeds. So maybe like this, although I don't think that this is already gonna get us that error. Nope, this is fine. Must not end with this. Here's the error. Here's when it's thrown. It's thrown when program address bytes is larger than the PDA marker, and every byte is the same as the PDA marker from the program address. So there seems to be something with this program address that would cause a security issue if the program address would also have the same bytes. Oh, that's when we create address with seed. That's not if we create a that's not if we create a program derived address. That's when we create an address with seed. Aha. And here, to make sure that we can't create an address that could also be a PDA, that's why we need to have that check. Oh, that's fun. See, we're learning stuff. Okay, but now how do I get there? We need the create address with seed, not the PDA. Base address. This thing will take the base address, the seeds, and then the program address. And the program address must not be the same as the PDA marker. Base doesn't matter, I can use whatever. Seed doesn't matter, I can use whatever. Or actually, seed is just one string in this case. And the program address, this guy now needs to be something specific, because like this, I won't get that error. But the last few bytes, and it's not enough that I do this. This would be too fun, right? Or too easy, because this is still base 58 encoded, so it gives me something completely different. But it would even be a valid, if it's long enough. Something like this, maybe. Yeah, that would even work. Or did I not save it? Yeah, this even works. Nice. This is a valid address, but it's not, you know, it doesn't actually have the bytes. So we need to do that a bit differently. We need to get an address that actually has the bytes. Hold on, let's get an address decoder. Get address, or the entire codec, why not? And we encode or decode an address. Oh, this is always confusing. Wait, I want an address from bytes, so I encode into the address. Nope, wrong way. I decode. I give you the bytes and I get the address. Yeah, that sounds about right. So new uint8 array from, and here I'm just gonna, you know, borrow the bytes from the PDA marker. And those are not gonna be enough bytes. My pseudo program address that I will put here. This will not work because it will get me, the address is not long enough. It's just 21 bytes and we expected 32. So we will need 11 more bytes. Good that I have something like this. That's 10, 11. It just needs to end with what the bytes are up here. I don't care. I got the program address cannot end with PDA marker. And just because I'm curious, what's the pseudo program address now? That would be the address. I mean, there are more depending on what I put as the first 11 bytes. But yeah, this one, for instance, ends with exactly those bytes, which it's not allowed to. That's fun. And now I'm wondering if the system program also checks that, because theoretically I could just, you know, still do it like that. Should we do that? Just because I'm so curious about it now? No, I won't. I still have other things to do. But that's cool, knowing that you can't have a program end with those bytes. I mean, it's a lot of bytes. You won't actually realistically find a program that has that. Well, what would be the attack vector then? If I had that? Oh wait, the attack vector would then be that those are the last few bytes of the actual program ID, plus whatever I put in the seeds, 21 bytes of what I have in seeds, and then I could sign for that address. Yeah, okay. And that's just 11 bytes. That's not... Probably the system program checks for that, yeah, for security. But yeah, cool. That's fun. I mean, yeah, learning something. I mean, did you know that every PDA has those bytes at the very end as seeds, the PDA marker? Did you know that? I mean, I did, but this is very niche knowledge. I don't think most Solana devs know that. Anyhow, we were looking at errors. So we were here. We managed to do this one. So we did one of the addresses. Then there's account related stuff. Account not found, one or more accounts not found. This one at least is relatively simple. I think you get it when you look up an account. like we did with the RPC. If we were to check on mainnet, I don't know, any of the ones, get balance or whatever, it doesn't matter which one, get account info. Pretty sure what we get back is this account not found, because this doesn't exist on mainnet. We just get a value null. Okay. But if we say get balance, then we get 0. Okay, fine. So for querying, this is not the problem. But latest when we send a transaction with that account, but that would then be a transaction error, not an account error. Okay, here it will give me, nope, too many requests because that's a resource intensive thing. So I'm getting blocked. I need some call where it expects that the account exists, something like get lookup tables or something. Let's pretend this was a lookup table. Accounts not found. Ha! Here I'm getting a one or more accounts not found. So we're getting close. Look, this is this one. That's the one or more accounts not found because we are requesting one or more accounts at the same time. But hey, we're on the right track. So this is a one or more accounts not found. Here we go. Yep. Accounts not found at addresses. This one. It's just one, but it's doing one of the requests where there are several. So it's the one or more. If I want the account not found, I need to find a different way to just fetch one where it expects that there is one. What other idea do I have? Get nonce from a nonce account maybe? It's probably in program system. Solana program system. Get nonce decoder, fetch nonce. How about this? There we go. RPC and my pseudo nonce address, which is not actually a nonce address, which is just an account that doesn't exist. Await this, and this time we probably get this one, hopefully. Yes! Account not found at address. Because the regular get account info, we just get null. There is none. The kit doesn't error. Because maybe that's exactly what we want, right? Maybe we want to check if there is something. And if we get null, then we proceed with something else, right? But if we fetch nonce and the account doesn't exist, then the kit says, well, that's certainly unexpected. So I will throw an error. And that's what happens here. We will throw this account not found. Boom. The account at error X. Nice. So with a fetch nonce, we can get this one. Cool, then failed to decode account, expected decoded account. That's probably if the RPC. Not too interested in getting to those. But yeah, we also got some account related errors. Then there are some subtle crypto related errors. That's, you know, with the crypto library, unimplemented. You might get that in the browsers, whatever. Not too interested in those. Cannot export non-extractable key. That's interesting. In the previous video, when we talked about GIL, we saw something about extractable keys because the crypto library doesn't allow you to extract keys unless they are extractable keys. So it makes sense that we have such an error. And then crypto related errors, the random values function unimplemented. You know, it's just, I don't think I would learn much from trying to get to that error because I would need to uninstall or overwrite some function, you know, whatever. Just not interested. And then key related errors. It's also interesting if we try to get keys but have different byte length and stuff, but it's similar to what we had with the addresses. Signature string length out of range. So if we try to create a signature from a string, similar with addresses, public key must match private key. Okay, and then we already get to the instruction errors. First, the instruction related errors that are not actual instruction errors, but related. For instance, an instruction is expected to have accounts. An instruction is expected to have data. And the program ID doesn't match. Different to this one, which is an actual instruction error, incorrect program ID. So could those be just errors that we get in the kit already? How would we get program ID mismatch? Yeah, I guess we have that in the kit. Right, if we assert is instruction for program and then it's not, well, then we get, well, okay, that's easy. There is an assert function and the error for the assert function is, well, the program ID mismatches. Yeah, so that's kit related. And also the expected to have accounts, assert is instruction with accounts. Yeah, if we assert that there are accounts in the instruction and then there are none, well, then we need an error for that. Okay, but those are honestly, wait, is then there also assert instruction to have data? Yeah, assert is instruction with data. Fun. Okay, yeah, but just for fun, hold on. Because this should be super easy. Expected to have data. Let's get this one. So there was an assert instruction with data. So this is gonna be easy for this instruction. This instruction is gonna be an instruction with a program address, system program. That's it. It has a program address and we assert that it has data, even though we don't put data. And what's gonna happen? Well, of course, we get the instruction does not have any data error. So that's an easy find, isn't it? Similar way how we could, program ID mismatch, we would do with assert is instruction for program my instruction for something else than the system program. Boom, like this. We also get the expected instruction to have program address and got system program. So yeah, that's easy, and we don't really learn much from that because it's literally an error that is thrown in an assert function. So that's quite boring, honestly, those three. The instruction errors, they are interesting. And there are a lot of those. Like a lot of those. A lot of those. Then there's signer related errors. Those are probably, again, kit stuff. So if we have in the kit already cannot have multiple signers or whatever, transaction cannot have multiple sending signers. I think the transaction sender is the fee payer. Can you find that? No, we cannot, but we can search for the text. There, if sending signers length. No, a transaction sending signer. Wait, that's something different than the fee payer then. Yeah, but those are internal errors. There we have the other one, the cannot have multiple sending signers. Partial signer, modifying signer. Maybe we should have a look at what those things all are. This enables wallets to inject additional instructions into the transaction before signing them. That's a transaction modifying signer. And we have a transaction partial signer without modifying the contents. And then there is transaction sending signer. Signs one or multiple transactions before sending them immediately to the blockchain. Ah, that's what it means. That's what it means. It has nothing to do with being a fee payer. It's only that this particular one sends it themselves to the blockchain. And you can't have more than one doing that. A partial signer will just sign it and be fine with it. A transaction modifying signer will modify the transaction and sign it, but a transaction sending signer will sign and then immediately send it. This interface is required for PDA wallets and other types of wallets that don't provide an interface for signing transactions without sending them. It's also possible for such signers to modify the provided transaction before signing and sending. We can only use a single transaction sending signer for a given set of transactions. It's the last signer because it's the one also sending. Nothing to do with being the fee payer, but it's got everything to do with being the one that also sends it. Yeah, we're learning something about the kit by looking at error messages. Error codes. But yeah, getting back to this, those seem to be all kit-related errors. Also those, the transaction-related errors, those are thrown by the kit. Signature missing, fee payer missing. I mean, those are protected through types. If we stay strict with the typing, then we should never get to those errors. But if we ignore types, then we theoretically could get there. And then the actual transaction errors, those errors, I guess we get back from the RPC when a transaction actually does not land due to a transaction error. And then we still get the granular errors, what kind of reason that the RPC didn't forward it or the validator didn't accept it, whatever. Invalid account for fee, for instance. Can be a perfectly valid transaction in terms of for the kit, but then the RPC says, well, the system program can't pay for this. So first, let's look at a few of those, and then we look at actual those. We already saw one from the codec, and I guess then I'm happy. Because this is already a long video. And I could make it way, way, way longer. So, transaction-related errors. Let's try from the top, why not? Invoked programs cannot pay fees. Gonna borrow some stuff from previous video again. Okay, all I'm doing here is sending a transaction with some compute limit and the price. This one should now actually fail from a account doesn't exist. It's not transaction related. This will actually be a transaction error, account not found. This one. This is the one that I would expect right now. Nope, it's not what I get. This is a Solana error, but it's a transaction simulation failed. Hold on, but this is exactly the error code I'm looking for. This one. Attempt to debit an account, but found no record of a prior credit. So there might be a nested error. So we have the context here. This is the error that we're getting, the 32002, and inside there's this one. So we have a transaction error inside a JSON RPC error, the transaction pre-flight failure. So this is the one we're getting. And remember, this one was also the only one that has with cause. So there's a cause in this one. So yeah, congratulations. We found the transaction simulation failed error. And the context of this one, hold on, let's improve our script here. If is Solana error, then my E should have a cause. Hey, out here, it doesn't. But in here, it does. And the cause is a Solana error. And then we proceed with the inner error. So let's look at this. Nice. So then the Solana error is attempt to debit an account but found no record of a prior credit. Because this is a Solana error and it's an error with cause. And then we should have the account not found error as the one that we want to find. Yes. Now we found the attempt to debit an account but found no record of a prior credit error. Good. But there was a transaction error. That's an actual transaction error already. We wanted to start with the invoked program cannot pay fees. And for that we need to add an instruction. No. For that we need to add a fee payer. Oh wait, but then we also need to sign for this one. Compute program budget thingy. What if we try to make the compute budget program sign this? Nice! That's already it. You found that this transaction includes an address which is both invoked and set as the fee payer. Program addresses may not pay fees. Error. Nice. That's the first one in the transaction related ones. Programs must not be writable. You know, we could do a lot of fun things. Programs must not be writable. Let's go back to my signer. Add an instruction to system program and add accounts compute budget program and role writable. And we add that instruction. No, not yet. This is a Solana transaction involved. Programs must not be hated, but that's what oh, hold on. I need to import this. And now, yes. The transaction includes an address which is both involved and marked writable. Program addresses may not be writable. So yeah, it's pretty simple to get those. I don't think we're learning much except, you know, that programs must not be writable, in case you didn't know that. And there are a lot of errors here as well that we could hit. Addresses missing, signatures missing, cannot encode with empty signatures. If we don't provide signatures, then it won't even let us encode that. Message signatures mismatch. So if we have different accounts set as signers, then we provide signatures for instance, or something. Yeah, but those are the more boring ones because those are the ones from the kit. Those are rather kit specific. The general transaction errors, they are Solana specific. Like they are actual transaction errors as the validators know them. So for instance, account in use. We already had the account not found. Account loaded twice. To get there, we would probably need to compile our transactions ourselves because the kit will do it correctly. Insufficient funds for fee. This one we could do though. Let's try this one. Program account not found. Also pretty simple. You try to call a program. Let's do program account not found. If we call, let's say, oh, I need little error as a program. We don't even need addresses here. Nope. What are we getting here? Which is both invoked and set as a fee payer. Oh, we are here again. Hold on, because this is also my signer. Well, then change one letter and boom, it's a different address. Attempt to debit an account but found no record of a prior credit. Yeah, so fair enough. So airdrop myself 1 sol to this address. Come on, I am human. There we go. Now, there we go. Attempt to load a program that does not exist. That's the program account not found, because that program certainly doesn't exist. And the other one we just wanted to do insufficient funds for fee. We need to have a certain, hold on, I'm gonna do a new address. A bro who is broke. Bro, you broke. Bro goes here. Rent 0 is this, and then we Solana transfer to the bro this much. Okay, now, so I've sent to the bro exactly enough that he has enough for rent, but now he doesn't have enough to actually fee pay. So if I try to fee pay with this guy, no. Transaction results in an account with insufficient funds for rent. It's a different error than insufficient funds for fee. Yeah, it has enough funds for fee, but not for rent. Well, in order to not even have enough for fees, we just need to pay more priority fees by bumping up the price. Congratulations, you found the insufficient funds for fee error. Because now we would have to pay so much in, transaction fees, priority fee mainly, that our 0.00089 sol are not enough for that anymore. And then it's not a rent issue, then it's an actual fee issue. We don't have enough for fees, and that's the error that we're looking for here. Nice. So this was that one. Invalid account for fee. What's an invalid account for fee? Maybe the system program, or maybe a bricked account, or I don't know, a token account. Hold on. Let's get a token, TOC5. We're gonna sign with this one with a decent amount. And like this, we will get another error like account not found, right? Attempt to add an account because there is nothing on it. I just needed to create this one because I need to sign for it. I need to be able to actually sign, because otherwise I get a different error before already, like a signature fail. Now I can sign with this one. It just doesn't have sol yet. So let's get some sol on there, but by SBL token, create token, this guy. So now I'm making it a token. There we go. That's now a token mint account. And I guess now if I try to pay a transaction, there we go. Nailed it. You found that this account may not be used to pay transaction fees error, which is also what we get if we have a bricked account, which now this basically is a bricked account. I cannot use this to sign anymore. No, bullshit. I can sign, but I cannot use this to pay fees anymore because it's not owned by the system program. Nice. So that was this one. Already processed. If we send a transaction which has already been received, that should be fairly easy to get. Let's go back to my one that can actually sign. We build a transaction. We sign transaction, send and confirm. And once the transaction is confirmed, we send and confirm the exact same transaction again. Then we should probably get the already processed. First one, it's sent. Now we're waiting for confirmation. Why can I not confirm? Maybe because the WebSockets with a public RPC are a bit annoying. I would need a better RPC for this. With a better RPC or another RPC. There we go. That's how it works. There we go. Easy. We sent the transaction, we confirmed the transaction, and then we get a transaction simulation failed. But this one is actually an error with cause. And inside, is the transaction has already been processed error, the 7050007. Congratulations, you found this transaction has already been processed error. And like this, we could keep playing forever, essentially, right? We could, block hash not found. That's a pretty simple one. Actually, that's so simple that I'm going to quickly do it. Instead of doing this, which is not exported, so I will need to manually do this. Okay, fine. Block hash, which is a string and this brand. So string, I don't know, system program, lol, to string, because otherwise it's an address. String is not assignable to read-only brand unique symbol. Same here probably. String is not assignable to. Okay, how do we make a block hash then? Probably from an encoder. Hold on. Get block hash. Yeah, of course. No, that's, wait. No, but we're going from bytes to string. What we want is from string to block hash type. There, block hash. That's what I need. See, learning something. So we need not an encoder, but just the block hash function from the kit, which takes the string. There we go. And now I can put in a string. Let's pretend that was a block hash. And the last valid block height is. And then if I put in that block hash here, then I should get my block hash not found. Let's see. Congratulations, you found the block hash not found error. Nice. Okay, and there's so much more to explore. Call chain too deep. For that I probably need a custom program. And more difficult ones like would exceed max block cost limit. We would need to put a lot of CUs into a block to reach that limit, but it could be an interesting exercise. I mean, that alone could be an entire video. Address lookup table not found. This one should be relatively simple. Too many account logs. So that's interesting. How many is too many? Unbalanced transaction. What even does that mean? So yeah, there's a bunch of interesting stuff here. And also with the instruction errors, call depth, custom error. Okay, that's not there are thousands of those. Duplicate account out of sync. There is a bunch to explore. So here's what we do. You go ahead and try to cause as many of them as you want. Maybe you see an interesting one and you're like, this one, I want to try out this one. And then if you don't manage, you come to me and tell me which one I should do. And then I'm going to do another video where I'm going to continue and I'm going to do a few more complicated ones. Because yeah, I can't do everything in one day. It's been 4 hours almost. Gotta stop at some point. But you get the idea. And really, it would be cool to go through all of them, but that would be a lot. But you can do it. Try to go through all of them, or at least the ones that you find interesting. Because I think there's still a lot to learn by trying to actually see those errors. Actually see that you managed to do them. I mean, this one is simple. Okay, this one was simple. But like, unsupported version. That should be relatively simple as well. You just need to tell the kit to ignore a few checks in the types. But yeah, I want to stop. I don't want to blow up this video. You get the idea. So we have a deal. You try and get more of those errors because it's fun. At least it's for me. It's this hacking, right? This trying to break stuff, trying to get to an error. Much nicer than trying to get rid of an error. How boring is that? And there are enough errors still for you to go through. So try them out and let me know in the comments which ones are the difficult ones that you want me to go through. Some are impossible, admittedly, but most of them, especially all of the transaction and instruction errors, those are for me the interesting ones. So let me know which ones you really want to see in a future video. I might do like 10 of them in another video. Because again, like the best way for you to learn is by trying out stuff yourself. It is okay to watch me do stuff, but then you also should dig in yourself and write some code yourself and try to cause those errors. And I will be here helping you out when you get stuck. Just let me know which errors you want to see and I will find them in the next video. Or one of the next ones. Till then, there are other videos you can watch. Give this one a like if you like the challenge. Subscribe if you have not done that yet. And I will see you in my future videos. Till then, bye bye. And good luck hitting those errors. Hit them. Find them. pause them, make the programs throw that error. I enjoy this because this is fun, right? This is nothing, I need to be productive and do stuff. No, this is just fun little hacking. This is how I enjoy my life.